So hello everyone, and welcome to this third JPEG NFT and fake media workshop. My name is Frederik Temmermans. I'm associated to IMEC and the University of Brussels, and I'm chairing the JPEG Fake Media Auto Group and co-chairing the JPEG NFT Auto Group. And while this workshop is called the third JPEG NFT and fake media workshop, in fact, we have had two fake media workshops before and two JPEG NFT workshops before. So this is actually our first joint workshop on both topics. So on the slide, you can see the program for today. So this time, we only have two presentations, and thereafter we will have a discussion particularly focused on the common challenges between topics, but also the synergies. For your information, so currently we're making a recording of the workshop presentations. When we start the panel discussion, we will stop the recording so that everyone is free to speak without having to worry about the recording. So I'll start with my presentation, which is just a minute, which is entitled JPEG Activities in Fake Media and NFTs with Common Challenges and Issues. So during this presentation, I will briefly introduce both initiatives and then conclude with some synergies between both activities that we can then later during the panel discussion come back to. But before I talk in more detail about JPEG Fake Media and JPEG NFT, it's worth providing some additional background about JPEG. So the JPEG Standardization Committee is most known for its image coding standards, including the widely adopted JPEG 1 and JPEG 2000, JPEG XS, JPEG XL, some of the more recent ones. But JPEG also made several specifications to enable broader imaging ecosystems, just as GP Search, for example, and JPEG Systems, a suite of standards that provide specifications for handling metadata, privacy and security, 360 images, and so forth. And in addition to these standards that JPEG provides, we also have some exploration studies. So these are basically we're continuously looking for domains that require exploration for potential standardization needs. And two of these that are currently ongoing are JPEG Fake Media and JPEG NFT. So why do we need these explorations? As said, in these explorations, we explore emerging domains and particularly focus on the need for potential standardization needs. And in an exploration study, we study use cases and requirements that we identify. And this first requires to sufficiently engage with relevant stakeholders, and that is something that we do through the organization of dedicated workshops like the one that we're having today. Once the requirements are settled, an assessment methodology and metrics to fairly evaluate the proposals needs to be developed. And then in general, the most common outcome of such an exploration is to issue a call for proposals, asking for relevant technology. And after evaluation of these technologies, the selected solutions can be collaboratively improved and combined and completed to address the identified requirements. And then the outcome might be included in a new standard, or it might lead to extensions of already available JPEG standards. So at the moment, JPEG Fake Media is close to issuing a call for a proposal. That's something that will happen in the coming months. That will happen over the course of this new year. And for JPEG NFT, on the other hand, That's a more recent activity where you're still exploring relevant use cases and also still engaging with the community and attracting new people to help us with this exploration. So now let's first have a look at JPEG fake media, which is all about media modification or manipulation. And while media manipulation recently gained a lot of attention, it's definitely not something new. There are multiple instances of image manipulations for various purposes, even before the era of sophisticated photo editing software. And this slide gives an overview of some notable examples, starting in '86 with the famous portrait of Lincoln. That was actually the print of a composite image where his head was added on top of a portrait of John Calhoun. So we have several of these examples over the last decades. And then if you look at the last one, this is a deep fake of Tom Cruise. That's one of the many deep fakes that went viral during the last year, during 2021. And this deep fake example symbolizes that while media manipulation in itself is not new, the techniques are becoming much more efficient, they're becoming much more accessible and much harder to identify or to detect that these are not authentic. When we focus in particular on media manipulation, it's clear that there are implications that might have damaging effects, and that's both at the political, at the societal, and the economic level. However, while media manipulation is often discussed in a rather negative context, it should also be noted that the creative industry has hugely benefited from photorealistic media manipulation. And in particularly, deep learning-based methods have made media manipulations or modifications, as we call it in a positive context, extremely sophisticated. Some of these applications include recolorization or restoration of archived media, content enhancement, such as denoising, resolution upscaling, and so forth. Other examples include content creation for movies and TV shows, and some famous examples include the TV show For All Mankind, which extensively uses deep fakes to bring characters like John Carson, John Lennon, and Ronald Reagan back to life in an alternate history storyline. And similarly, in the movie Gemini Man, Will Smith plays together with his younger alter ego, also thanks to the deep fake technology. Now, a first reactive approach to deal with media manipulation is detection. But this approach also imposes several challenges. So, for example, these detection algorithms typically only distinguish deep fakes from genuine data without considering harmless AI-based media processing. Another major challenge is access to sufficiently large databases of typical manipulations in specific use cases with reliable labels. Also, a general weakness of AI-based approaches is that what we call the black box challenge, which makes it difficult to know why and under which circumstances the approach fails, or more importantly, how to improve it. And then an inherent challenge in any detection paradigm is what is also referred to as a cat and mouse game. So on the one hand, the performance of detection methods improves, but at the same time, the performance of generation methods improves as well, and they play a catch game. And in this context, it's also worth noting that the adoption of technology plays a crucial role for this purpose. So for that reason, an alternative, more longer-term vision is to rely on signaling of associated provenance information of media assets. And also in creative use cases, the ability to signal provenance and authenticity information in an interoperable way enables full transparency about the nature of the content towards the end users. And according to the JPEG fake media definitions that we have defined within the group, the provenance is defined as a set of information about media assets, including the trail of modifications starting from an actor. And then an actor can be human or non-human being, like software or hardware, that participates in the media ecosystem. So common actors include the camera that was used to capture the asset, the photographer himself, the editor, the editing software, and so on. This also implies that the provenance information does not necessarily span the entire life cycle of an asset, and that can depend depending on the end user. And the schema that you can see on the slides shows an example for that. So this is an example of a wedding photographer who makes a picture and then shares it with the client. If you look at the provenance information that it's relevant for the photographer, that starts from what comes out from the sensor from the camera up to the high quality version that is shared with the client, which we then typically call the digital master. And then for the client itself, it only starts from this digital master, but then again, new versions might be created if he shares this photo on social media, for example. Then the resolution will be decreased and it might be done transcoded to a different format and so on. So depending on the actor, depending on the use case, the provenance trail might be different, or the part of the provenance trail that is relevant might be different. Of course, in such a provenance model, interoperability is essential, as well as the security. If you have this provenance information, you should be able to rely on it as well. So such a model should allow description of information about the creation of media assets, as well as all the modifications like transcoding and so on, as we've seen in the example that have happened to it. And in some cases, additional information about the actors might be needed as well. And again, all of this, of course, also has to take privacy into account. So depending on the exact use case and the specific version of an asset, the information that is or is not available might different. And this provenance model is a vision that's pursued by some other initiatives as well, like the Content Authenticity Initiative and Project Origin that now merge into C2PA. And also within JPEG fake media, this provenance model is quite a crucial element, while, and I'll come back to that, I also have to say it's not the only part. So this brings us to the scope of JPEG fake media, which is the creation of a standard that can facilitate the secure and reliable annotation of media asset creation and modifications. And while the name might suggest otherwise, it's very important to stress that the standard shall support usage scenarios that are in good faith, as well as those with malicious intent. So we focus on both sides of that. So JPEG fake media aims to offer an interoperable, secure, and trustworthy annotation ecosystem, both for signaling detection and validation metadata, as well as provenance information as a more long-term sustainable solution. So JPEG fake media has the objective to engage with stakeholders to better understand applications and scenarios relevant to these use cases. And from the use cases, we extract requirements for a potential standard that should provide a solution to these requirements. And that future standard should ensure interoperability between a wide range of applications dealing with fake media. So therefore, the standard should be able to signal provenance information along with relevant contextual information. And obviously, the standard should provide this with mechanisms that can provide security, protection, integrity for both the metadata as well as the associated content. So based on all the contributions, based on the previous workshops and so on, the slide shows some clustered use cases that have been identified. And as you can see, they have been organized in these groups of bad intent and good intent. Of course, the list of use cases that's presented here is not complete and will be further extended over time, but it's already representative for a first set of requirements that have been drafted. So at this point, we have quite an extensive set of requirements. I have not listed all of them, but you can find them in a public document that you can find on the JPEG website. But these are organized in these three categories. So media creation and modification descriptions, the embedding and referencing, and then the authenticity, integrity, and trust model. Now, that's it for JPEG fake media. With NFT, as said, we're a little bit earlier in the process. We're in the process of identifying all the use cases, identifying what the actual challenges are, and extracting requirements. So just in a nutshell, non-fungible means non-interchangeable. So basically an NFT is the alternative of, for example, a painting that you can not just exchange for another copy that you can do with money. So basically what cryptocurrencies are to physical money or NFTs to assets, physical assets. So the digital equivalent. So that's what's also illustrated here on this figure. Looking at the use cases, we've seen in 21 that NFTs, or at least the market for NFTs, basically exploded, and there's one example after the other of NFTs that sell for millions of dollars, and these are just a few examples. There are also particular cases where you have twins between physical assets and a digital asset, and that can work in both directions. This is an example of this chair, which only exists in the digital world, and same is happening for these shoes and virtual environments and so on. Same as with fake media, there's several challenges related to NFT, lack of interoperability being one, but also the long-term viability, the reliability and security. There has been a recent example of somebody who published an NFT on different NFT platforms, and since the NFT is only a URL to the asset, in this particular case, the asset itself was programmed to be different depending on which platform was referencing to it. And it was just one case to illustrate how vulnerable the current situation is, because not even a hash is mostly recorded in the blockchain. So in general, there's also need for best practices, and also the legal framework is something that needs to be worked on. Then one of the questions why JPEG should pay attention to NFTs, because many others are paying attention to NFTs as well. Well, images, digital media are quite an important part of the NFT world. Many of these assets are already or can be represented in several of these JPEG standards. We're thinking of typical pictures, but also of 3D objects, for example, with the JPEG Plano standard. Just as with fake media, there is a need for interoperability on the metadata side, as well as protection of that metadata, so ways to guarantee security. It's another example of interaction between blockchains and DLT and imaging. So in the past, we've also had an auto group focused on blockchain. So some of the elements that we identified there are coming back within NFTs. And in general, there is a need for media-aware and network agnostic international standards specifically for NFTs. So looking at the next steps, it's similar to what we see with fake media. We have to explore all the use cases and identify the requirements and engage with the community through the organization of workshops. Talking about workshops, for this particular workshop, our focus is on common challenges, but also synergies between fake media and NFT. So we will have a discussion session at the end, but I already listed just a few of these synergies as an inspiration for the discussion session later. So one of them, if you invest in NFTs, then surely you will also be interested in the provenance of the media asset that you're investing in and the trustworthiness of that asset. On the other hand, within fake media, we're also looking for ways to set points in time of that provenance chain, and that's something which is done exactly by NFTs because they record an immutable record of a transaction. Then in both cases, both for fake media and NFT, I've talked about this interoperable metadata. So the embedding, the referencing of metadata, the security of the metadata, the linkage between media and a record in a blockchain, or between the content and the metadata, all these things are common elements that are required between both activities. Then looking at some of the technical solutions that we think are relevant, we see some common interest there as well. And perceptual hashes is one of these techniques, or visual media descriptors. So they provide or might provide a solution to some of these challenges in NFT and fake media. But of course, then we need to assess what the possibilities are and also what the limitations are to know whether they really do provide a solution or not. So that's just a quick overview of a few challenges, and we go much deeper in that during the discussion. Just for reference, here are a few contacts. All of us are in some way involved in activities by chairing the ad hoc groups or the requirement subgroup within JPEG. And if you're looking for more information about both activities, you can check the jpeg.org website, where you can find our public document and also recording of our previous workshops. So that's it for me. Before we make time for questions, we'll first listen to the second presentation from Daniel Marikik, which is entitled Introducing Copyright 3.0, No Need for NFTs. And then we'll come back with questions during the discussion session. So that's it from my side. I'm going to give over to you, Daniel.
Thank you. So if you can stop sharing your screen, please.
Oh, sorry,
Frederick.
yeah.
So yeah, because we can't do it together. And share the screen. Excellent. I hope this works. So yeah, hi, I'm Daniel Maricic. I'm the CTO of Kelp Digital and Anagole Network. And today we're going to be talking about one of the approaches of how we can bring trustworthiness to the NFT market, and do we even need an NFTs? I did not see the previous presentation, and I'm really glad that there were 3 slides talking or questioning certain things that we're going to be discussing in this session. So to start, here's a little disclaimer. This will be slightly technical talk, and knowledge about NFTs and blockchain in general is required. So, and I mean, when I mean blockchain, I mean, you don't have to know anything about the blockchain, like how actually it works, but you need to know what are the links and what makes it so special, and what makes it so good option for the distributed databases. So let's start talking about NFTs. Are they really unique? The short answer is no, but the longer answer is that they are not unique because of the way how they are implemented at this point in time. When you mint an NFT, in any blockchain solution, it essentially gives you a sequential ID starting from 0 or 1, +1, 2, +1, 3. Every time when you mint an NFT on specific marketplace, which is also a blockchain, either built on top of Ethereum, or it's a random or custom-made blockchain, they all have the same implementation. It is increased, it's a natural number increased by 1. That is unique in the specific set of circumstances when you're looking for uniqueness between 0 and unlimited amount of number, but it's not unique across any other blockchain, because 100 is unique only in one context, but 100 is not unique globally. The NFTs are, as they are currently implemented, are not content aware. And that means that they don't look at the content for the identifiers, that they are using either randomized UUID version 4, or they are using this kind of natural number increased by 1 identifiers. On the other hand, is that NFTs should be unique, and the marketplaces are making them making NFTs available that they are not unique. If you, for example, resize an image and slightly skew it or change the colors, you can recreate a new NFT on the same marketplace, which is not basically a definition of NFT. What's most important about it, that it's a lack of a proof of a copyright. We have wrote an article how one of our guys stole my NFT that was worth 10 Ethereum, and she was able to sell it and on a completely different marketplace, which, as Frederick said, there is a lack of interoperability between the marketplaces or NFT services. Because of the lack of interoperability, they cannot know who is selling what. Is that already unique or is not unique, which effectively renders NFTs just as any other digital asset. Well, the copyright, we call it copyright 3.0 because it's Web 3.0, decentralized, distributed, and we are trying to bring as much as transparency and linkage to the digital asset as possible. The way how we are doing that is rebuilding and questioning everything that we know about the copyright in the digital world. The copyright 3.0 is based on the content. We all know that a single image, 1,000 times 1,000 pixels, has unlimited amount of possible renditions, possible modifications. NFTs, as they are now, they just cannot cope with that amount of different renditions. So you buy one single image, and then it's up to you what you're going to do with it. Many times you just buy a metadata file that contains a link to an image. On copyright 3.0, it's trying to solve major problems when it comes to trustless identify in a trustless and transparent way of identifying what is the image. That we call proofs in our Anagolate chain, which we are building for the rights management, and we call those proofs because every image or every photo contains multiple identifiers. Perceptual hash of one can be a perceptual hash, other one can be a cryptographic hashes of different versions of the sections of the photo. However, a developer choose to create the proofs, they can be recreated given the same data, which is completely private and never stored in chain. The copyright 3.0 contains the it should be that the rights is done correctly. If, for example, NFT stands for non-fungible token, and if that's a painting, and we say that it's a digital asset that is unique, it should be unique, then whoever buys an NFT, it's, as per definition, it should be an exclusive right transfer, which means that if I sell an NFT to any of you, I lose and you gain. That's the point of non-fungible token. And that is not how it's done currently. With copyright 3.0, that's going to be possible. And on the top of that, you could create more dynamic licensing models and modify your images to suit certain purposes, and so to share somewhere, and you want to share them, for example, only on one blog and not on the other blog, or that is completely forbidden on Facebook and so forth. The copyright 3.0 also includes percentage-based copyright, which makes a lot more sense in the current world when there are many people involved in creation of a certain media, either photo or a video, where the copyright can be shared in a different kind of percentage based among thousands and thousands of people. So not necessarily, you don't have to buy 100%, you can buy 10%. We are working towards defining the copyright 3.0 that is not affected by removing the metadata, because it's a widely known fact that metadata is cool, everything is good about it, but it can be easily removed. And due to that fact that it can be easily removed, it is removed. So the moment you remove the metadata, you generally lose the track of who is owner, how is it created, when was it created. Everything can be changed. There are no read-only fields unless they are EXIF image with the dimensions which are taken from the bytes itself. And in this case, once the user can claim the copyright, every rendition after that carries the copyright. So all the unknown amounts of renditions are protected, and they can always be tracked back to the user who created the copyright. I hope I'm not going too fast, and I hope you guys are not lost, because now it's going to get a bit more complicated. Everything is all right. Perfect. So this is how is it done? Is it on a high level, from a high level point of view? We are introducing the thing called workflow, which is a transparent. It is reproducible, and it is always the same. Once created, it can be used anywhere, from the International Space Station to planet Earth, planet Mars, or whatever we choose to go. It does not change. What the output is going to be the same based on the input data. You might say, well, that's obvious, right? Well, it's obvious and easy, but it's not. So let's go through this. So on the right-hand side, you will see that there is a beautiful little image of universe and the Doctor Who TARDIS, which is, well, space and time, right? What we want out of this is to get the left-hand side, which are identifiers, or how we call them in Anagole network and Anagole blockchain, the proofs. Each of these proofs is describing the image in a certain way. Some identifier will describe a certain parts of an image. For example, just raw pixels. It can just take the metadata. Another one will be a perceptual hash of the image, or something else that we did not think of at the moment. All these proofs are important for creating the claim and essentially creating the copyright statement. But what's important is that even if there are changes in the photo, let's say that we have resized the photo, few of the proofs are going to be different, and some of them are going to be the same. So if we would like to have a kind of a comparison, is this correct image? Is this similar image? We can go and look for the weights of the proofs. Which one has more weight to be an unchangeable constant? In our case, it's going to be image perceptual hash, because it is not cryptographic hash. It's a feature-based identifier. It's a local sensitivity hashing method. So we are introducing a way to identify a specific set of data, or in our case, image, 100%, which would mean that, okay, so we have two cryptographic hashes, which we all know that if the data changes in the slightest, the cryptographic hash changes completely, which is good for identifying a specific set of data 100%. But it's a horrible and terrible way of comparing if a slightest change is introduced in the photo, but yet again, the photo stays the same. And that's why we have a perceptual hash, which changes according to the photo that has been changed, because the feature changes. So essentially, even the black and white photo of this specific universe will render the 100% the same image perceptual hash, but both cryptographic hashes will change. So in this case, we are creating a base for a transparent and provable process of obtaining the identifiers without pretty much trusting anybody, but the process. Everybody can create the process. Everybody can store the process on the chain. There will be a governance on the chain for people who's going to be verifying these workflows and making sure that people are good actors in creating of this, and then people just use it. We can use the same workflow today and in 100 years, and it should not change. Given the same data, we will always get the same set of proofs. And so the base is content addressing. The base is content addressing, which looks in the content itself, where now comparing to the NFTs, it doesn't. So here's a little story about metadata and the standards, and why is it such critical for us to implement this, the workflows. So we have 8 images here that are taken from different equipment. So Canon, Sony, DJI is a drone, Realme and Huawei are 2 smartphones. The point is to see how the metadata differs from a different manufacturers and where the serial numbers are coming in, and how can we identify the photo in a conventional way. If we would say, oh yeah, the photo ID is that one, but we don't have that. In many cases, the original document ID is generated, but it's always generated by the software, but not by the camera. So we need to introduce the workflow that knows how to incorporate the metadata, important metadata fields, plus the content, combine them together and create one standard and package it nicely so it's transparent, provable, and always available as a copyright 3.0. So these are the camera makers and camera models. And as you can see that all these two are mobile phones, and they do not provide the serial number of the camera, which is not correct way to use the metadata, and it's not possible to trace back the image to the real world asset. And this is the same thing goes for the lens. Also, on the other hand, is that all these things, original document ID is not written at all. So again, there is no way to using the conventional metadata fields to track the uniqueness of the photo taken by the smartphones. But yeah, so majority of the content creators that they use smartphones, which is a huge amount of data and a huge amount of photos that we cannot just account for. We cannot connect them to anything unless we go digging deeper and somehow we can find that smartphones are actually putting the certain identifiers in the software, which is completely optional and not the correct way to put to use this field. So much about the IPTC and all the other XMP standards. Last but not least, to sum up all the stuff that we have talked about, this is how the copyright 3.0 looks like when stored on the blockchain, on Anagole network. There are three components: account ID, which is a blockchain address, an owner of the field, or owner of the record. The owner can instantiate the transfer of the rights. The owner pays the fees, and the owner is the owner of the statement. Then we have signatures, which are public key infrastructure signatures. So in our case, it's PGP key used for a holder or a user who is claiming the copyright, and an issuer. It is a subject address, the blockchain network address. Both of them signing the claim data, effectively rendering it legally valid and legally binding contractual statement, which carries all the necessary data to recreate it given the same input data. In our case, the universe with the target photo. And not to go, if you are interested into the more details about the claims and the signatures, as you can see, the proportions are 100%. Holders and issuers are addresses, and there is no private data shared here whatsoever. Only public keys as per PKI standard, and the validity time, and that's about it. The last slide is ecosystem and the central applications. Just to make it clear, Kelp Digital and Anagole Network, they go together. Anagole Network is the blockchain, custom-made blockchain for the rights management, not just for photos, everything, videos. We are working on to have it very generic to support also music industry. Eco-friendly and secure. As I said, no private data is stored. No data, image data stored on a network. The network acts as a distributed database, linking things together. The network will also have utility token, and the token is used for the paying network fees, buying, staking, and validating the chain. Where the Kelp Digital is a user-facing application, which is hybrid application. It's not fully 100% this decentralized application. And it is used as an entry point for users who want to claim the copyright of the photos, claim the ownership of their physical devices like camera lenses, and who wants to sell the copyrighted images on the Kelp marketplace, which you can either license under non-exclusive licenses or exclusive licenses, which then acts as a NFT should be doing since the start. Different kinds of integrations, Lightroom plugin, Capture One in the future, and then probably the most important part of the privacy and security is that Kelp Digital has no idea what's behind the data. Everything is distributed and everything is encrypted. So there is no way that there is, even if there is any security breach, Kelp will just not know what's behind what people are storing. Yeah, thank you very much. Here are the links about some articles that we have done. I will leave this as it is, so maybe you can scan if you want to read it. We will provide the PDF later. And yeah, I hope you had fun, and I hope I did not go too fast.
Thanks a lot, Daniel, for the presentation. It was nice to see that even though we didn't see each other's presentation before, and
yes,
there are some links between the two, so that's a good starting point for the discussion, I guess. So what we'll do next, we're going to stop the recording here, and then we'll have some time for questions and discussion. If I look at the list of participants, I see quite some familiar names, but also quite some new names.